I'm going to introduce a very interesting technique. This is an idea that was there about 100 years ago, but as a problem. People didn't use it as a technique. A few years ago, I realized when I was solving problems that this is an extremely useful technique for solving problems very quickly. So I'll just tell you the technique first. I have a nice interesting proof for the statement that I'm going to write, but I'm not going to prove it here. You can look up and read the proof without using projectile at all, because the whole thing can be proved without using the idea of projectiles. So let us see this idea first. So if I have a projectile path, and here we are talking about ground to ground or same height projection. Now you pick any point, you let's say pick this point or this point or that point, any point on the path. You can join it to the starting point and you can join it to the ending point, right? Now this point makes an angle A at the starting point. This point makes an angle B at the ending point. Now if you look at tan A will basically be this height divided by this distance, tan A, plus tan B, which is this height divided by that distance, tan B. Tan of the angle subtended with the horizontal at the starting point, tan of the angle subtended at the ending point, turns out to be tan theta. Now theta is the angle of projection. This angle is theta. So that is tan theta. Notice tan A is not the same as tan theta. Okay, because this is a point which is somewhere there. So tan A is much less than tan theta, right? Now tan theta is tan A plus tan B. This statement turns out to be extremely useful. So the power is not in this statement, the power is in how you use it. Let us look at an example. So for example, if the question says, and by the way, this kind of a question used to come up a lot in NEET, doesn't come up anymore. But now if it does come up, you can solve this in less than half a minute. Let us see how, or not even half a minute. Suppose the question says that the range is equal to the maximum height. Find the angle of projection. So what is this? Height. What is the range? Well, that is the range. It's equal to the maximum height, which means half of the range will be h by 2. This will be h by 2. Correct? Because if this has to be h, this will be h by 2. That will be h by 2. Now if I look at tan A, what is tan A? Tan A is h by 2, which is 2. Right? Because you take the 2 up there, it's basically 2. What is tan B? Also 2. What is tan A plus tan B? 4. So therefore, tan theta is equal to 4. That's it, over. So if the question was asking you about theta, you will say theta is equal to tan inverse 4. Now it looks like there is no question here because you just found tan A and tan B. But that is the power, because otherwise you will have to write down H formula, you will have to write range formula, you will have to equate, you will have to then write down what is tan theta, etc. This makes things a lot simpler. But this is not the only case. Let us take another example. Okay, so in this kind of a question, particularly in hard questions, you will find tan theta is tan A plus tan B turns out to be extremely useful. Okay, now the proof of this you can read up, but I'm not so interested in the proof. I'm interested in your application for this. Now, which point is tan theta equal to tan A plus tan B? Which point is it valid for? Any point. Which means if I took this point, I can write tan theta is tan A plus tan B. If I took this point, tan A and tan B will both be equal. So 2 times tan of this angle will be tan theta. But I could also do this point and that point. I don't know what tan theta is. So let us take this point. Here you got tan A plus tan B. How much is that? Tan theta, which we don't know. But if in this case you knew this height and you know the range, that means you know tan of A dash. And tan of B dash is the same as tan of A dash. So it is 2 times tan of A dash. So can you see that you can actually just say 2 tan A dash is tan A plus tan B. You can also take this point and some other point and say tan A plus tan B is equal to tan A double dash plus tan B double dash. You can apply it like that. You can also apply it to directly find out tan theta. Anyway, this turns out to be an extremely useful idea. Let us look at a couple of examples. So here I have a question. There is a building of width 40 meters and height 30 meters. And you are 15 meters from the building. You want to throw this ball such that it just grazes over that surface, that is this part of the building, goes over to that side, just grazes over that side and hits the ground. You understand the question, right? So it does this, just grazes over, goes like that, and just grazes over there and then comes down like that. You know from symmetry that this must happen right in the middle, right? So this must be 20 meters, that must be 20 meters. And not just that, if this is 15 meters, that must be 15 meters. So all this you know from symmetry. So this doesn't require a lot of trick. Now the question asks us, what is the angle at which you are projecting, angle theta? And we also want to know what the maximum height is from the ground, maximum height of the ball from the ground. So I throw it and basically I want to find out what is that height. How do I go about doing it? We can write down u cos theta, u sin theta. You can solve this for 2-3 pages, or you can use our nice trick. Tan A plus tan B is tan theta. How do I use that trick? What is this height? 30. So pick this point. Do I know what is tan A? Well, do I know this? 30. So what is tan A? 30 by 15. This is tan A. What is tan B? Well, tan B means you should take the same point and join it to that other end. You can pick any point you want, but you must join it to the two ends. And this will, by the way, only work if you are in the same level. You start and end at the same level. So if you join this, so that would give me tan B. What is tan B? 30 divided by this distance. Now what is this distance? 40 plus 15 is how much? 55. So tan B is 30 by 55. 40 plus 15, 55. Okay. So you can simplify this. This is 2. And if I cancel out 5, this is going to give me 11. That's going to give me 6 by 11. So tan theta is tan A plus tan B. So that is 22 plus 6. How much is 22 plus 6? 28 by 11. So angle of projection theta is tan inverse of 28 by 11. That's it, over. The question didn't involve anything more than this. If you see, this question otherwise would have been quite complicated. Once you use this idea of tan theta as tan A plus tan B, this becomes really, really short. Now what about maximum height? You may say, okay, this is all fine for finding theta, but this question asked me to find the maximum height. How will I find the maximum height? Actually not a big problem, because let's say the maximum height was h. This point is also a point on the path, right? So if I join this point to this end, you will get an angle A dash. How much is tan A dash? H by 15 plus 20. How much is 15 plus 20? 35. What is tan B dash? Well, since it's a symmetric point, B dash is the same as A dash. So that means that will also be h by 35. So what is tan theta? Tan theta should be 2 times h by 35. Is that clear? But you already know tan theta is 28 by 11, because tan theta is also this plus that. Tan of A plus tan of B is tan theta. It is also equal to h by 35 plus h by 35. So 2 times h by 35 is 28 by 11. And so that means I know what is h. H turns out to be 35 into, if I cancel this out, that will give me 14, right? So 35 into 14 by 11. So 35 into 14, this is 70 into 7, 7 7s 49, 490 by 11 meters, right? So the maximum height h is 490 by 11 meters. So if I now divide 490 by 11, you will end up with some 44.54 kind of thing. as an approximation. Okay, but the basic idea is very easy to calculate the maximum height and very easy to calculate the angle of projection. By the way, since you know the maximum height, you can now use that to calculate the time. You can use that to calculate the vertical velocity, because you will know the vertical velocity there. And since you know the horizontal range, you can calculate the horizontal velocity as well, because you know the time, right? So once you know the maximum height, you can find a lot of other things. So this basically simplifies the problem very, very, very significantly. Now this idea of tan theta is tan A plus tan B for any point, and that's extremely useful. Now this used to be a problem, like I told you, but it was a different type of a problem. It was a problem where there is a triangle and somebody wants to throw it from here to there. What I realized was this is something you can use in many, many questions, particularly because you can choose one point here and one point there, you can combine it. So, but this technique is not something that is commonly known. So if you have to basically answer in your exam, you cannot use this and basically say, if they say find the angle of projection, you can't just write tan A, tan B, therefore the answer is tan of theta is 28/11. That won't be allowed. So you will have to solve it the hard way, but you can definitely use it for checking. And in a lot of competitive exams where working is not required and you don't have to worry about your method, in that case you can definitely use this as a very quick solution technique. So as long as most people don't know that such a technique is available, you have a great advantage because you can keep trying this out. Okay. Now please remember, this works under a specific condition. The starting and ending point must be at the same level. The same condition that you can use all the projectile motion formulas for. That is the same condition that must be satisfied here as well. Okay. So this is a very good shortcut that you can practice a few questions with. Remember, tan theta is tan A plus tan B. So you can use that for checking or in certain cases for solving as well. But difficult problems, always think of this. If you get stuck at a problem, think of whether you can use this from a convenient point.